All right, great. So thank you everybody for joining us in today's webinar. I'm Christine Tobin, Manager of Customer Success. For this session, our Wi-Fi engineers, Jacob Wilson and Adam Wilson, will be providing an overview on leveraging Wyebot for 24/7 optimization. Jacob will provide the technical presentation while Adam will answer any questions you may have via the Q&A feature. Jacob will share ways that Wyebot can be used to help you ensure your network is performing well 24/7. And more specifically, he'll discuss troubleshooting specific issues, setting up customized network tests, and enabling proactive notifications. We want to make sure that you're getting the most out of our solution. So we hope this session is helpful and provides you with additional knowledge so you can help you out in your day-to-day troubleshooting and monitoring efforts. Your subscription with Wyebot includes not only year-round support from our team of engineers, but also training. The customer success team will keep you informed on training webinars just like today. This session will be recorded and uploaded to your dashboard. And to navigate to the recording, simply go to the Help tab, Documentation, and then there's a Webinar tab on the bottom left. Again, during the call, if you have any questions, please use the Q&A feature by typing your question in, and Adam will respond accordingly. Thank you for being here, for your valuable time, and I hope you enjoy the session. All right, thank you so much, Jacob.
Thank you. Yeah, let me go ahead and get this started. Okay, so I'll share the screen here and make sure I'm tabbed over correctly. Okay. All right. Yeah. Well, thanks, folks, for attending our little webinar here. And yeah, so the focus today is going to be how to actually leverage Wyebot's technology and use it. In a sense, we're going to give you some methodology for troubleshooting and setting up tests, etc. Really, the idea is we want to have you folks get the most value you can out of your solution, right? With Wyebot. So a little bit about me for those who maybe haven't met me at this point. I am the sales engineering manager here, which really just means I'm kind of I get to deal with or work with some excellent Wi-Fi engineers and customers, and look at people's networks, provide advice, and help out with support. Right, we're always here to help you, and that's kind of what's fun about the job, right? And I live out in Phoenix, Arizona, and just kind of enjoying the weather. We're getting past the summer, which is always nice when that happens because it goes on for a very long time out here in the desert. Anyway, so the topics for today, so really it's going to be some tips for the most part, right? Some ideas to get the most value out of the solution, and we're also going to do a live demo. Actually, that's where we're probably going to spend most of our time, is looking at an actual dashboard. I'll walk through some of these features. I'll give you some ideas as far as troubleshooting, tests, examining the issues, all that sort of stuff. All right. So that's hopefully, after the session, you can go away from it with a little more, comfort with how to use the solution and analyze the data. Right. And just a quick refresher on the Wyebot technology and how it works. I'm sure most are at least somewhat familiar at this point with this, but we are a sensor-based solution. So you have these sensors that you deploy strategically throughout your environment. The sensors are multi-radio, which means we're able to simultaneously do analysis, like spectrum analysis, packet captures, things like that, while also acting as a client with synthetic network testing, right? That's why we have multiple radios, so we can do all these things at the same time without any type of time slicing, which is, of course, important as far as, not missing events, things like that. Now, we're also vendor agnostic, which means we work with any Wi-Fi vendor, and in fact, with multiple vendors at the same time. If you have a multi-vendor environment, we can help facilitate that. Automated troubleshooting. We'll talk more about what that means as I go through this presentation, and also notifications. Right, that's the feature I always like to encourage you to take advantage of is getting proactive alerts with the sensor. It's that way you don't have to be logged in all day trying to find issues, right? So just some screenshots here. So when I say vendor agnostic, you can see our access points tile. This is from a dashboard. I think this is in our office out in Boston, but you see all these different APs, right? We have Extreme, Meraki, Ubiquity, and we display them all in a very similar way, right? Because at the end of the day, Wi-Fi is a it's a protocol that is pretty well defined at this point. So interoperation is pretty good, right? And we help ensure that by making sure your different vendors are coexisting, right? Not having a bunch of channel overlap and things like that. So vendor agnostic is a big part of our solution. The automated issue detection as well, right? And we're going to go through this in the live demo in more detail, but you can see we give you problems. So we're finding, misconfiguration. Commonly you'll see things like legacy data rates turned on, intermittent issues like overhead being too high, stuff of that nature. And we also give you a solution to help you understand what to actually change to address the issues, right? And that's the missing step you often have is, there's a problem, but you don't know how to fix it. So we try to help you with that. Okay. Now the active testing, this is when we refer to it as synthetic network testing sometimes. But this is where the sensor is an actual client on your network. It can run tests on the Wi-Fi on any of your SSIDs, as well as the Ethernet, the wired side. And you can see here a screenshot of our network test analytics, which gives you an at-a-glance view, pass-fail percentage, as well as DHCP, DNS, and in fact, radius performance. All of that stuff is being measured for you, and you can see everybody likes a pie chart, right? So we give you some of those, and we'll get more into this stuff in the live demo. And the notifications as well, right? So we have a customizable alerting system where you can do, it is email alerts, right? But what you're able to do is you can specify specific, users and set up trigger criteria. So, for example, you might not want to get alerted every single time an event is triggered, right? Maybe you want to get alerted if for example, you have a ping test that goes to your some IP on the internet, right? And if that fails once, who cares, right? But if it fails 5 times in a row, that may be a bigger issue. So we let you customize that, and again, we'll explain that more as we go through. All right, so I also want to give you some advice just generally about using the Wyebot sensors. When I say using, I mean placing, right, for deployment. So we're an over-the-air monitoring technology, which means the vast majority of the data that the sensor gets and uses and displays on the dashboard is collected over the air with Wi-Fi radios. What that means is it's important that you have the sensor placed in an area where at least Wi-Fi coverage is good. Now, if you are, let's just say you have a bunch of these sensors and you're running cables to them and you want to know where you should run the cables, we would recommend having them nearby an access point, within, 6 to 8 feet or so of those APs. Reason for that is, if you're taking a wireless packet capture and you want to see what's going on a given service area of your Wi-Fi, the access point is the central point of that service area, kind of, by definition with how the clients are all connecting to it. So that's where you're going to hear the most, as far as packets and things like that. But of course, right, it's not always possible, right? So as long as you have the sensor deployed in an area where Wi-Fi coverage is good, is solid, we're going to see plenty of useful data and give you lots of valuable information. Now, there is a concept that we talk about that's called optimal coverage, and that means you have enough Wyebot sensors to give you full visibility of your wireless network, and that usually breaks out to roughly 1 sensor per every 6 APs, depending on things like building construction and density of access points, things of that nature. But the point is, if you have enough sensors to give you that full visibility, you get that 24/7 automated optimization, which is pretty nice, right? Because then if you're having an issue in some area, well, you've already had a Wyebot sensor there, right? So it'll tell you what the problems are, and you don't have to reactively, take down a sensor, move it to that area. That takes time. You have to be on site. So it's good to have optimal coverage. But of course, if you don't, just try to have those sensors in areas where those issues are happening, and where Wi-Fi is good. The main point here is just avoid installing sensors in areas where you're in a sense isolated from Wi-Fi coverage. Like, one example would be in an IDF closet on a network rack in between a bunch of switches and servers. Well, that's going to block your wireless signal quite a lot, which means the data might not be so useful from Wyebot. I mean, it'll still see something, right? But generally speaking, try to get it in an area where where we're going to see access points and wireless, but it's not as picky as I'm making it sound. It'll work, right? But just, if you're asking for advice, this is what I'd say, try to keep it in those areas where you have good wireless coverage. All right, so some quick kind of methodology around troubleshooting with Wyebot. Well, Wi-Fi troubleshooting in general, right? I think the first step that you want to look at is, defining your problems, defining the scope of the problem, right? Is it affecting multiple users? Is it affecting just one user, right? Is it a specific website that's not loading? Is it slow speeds? Is it disconnections, right? It's important to define these issues because I think, as you know, right, a lot of times when you get a ticket from your from an end user to your help desk, they might say something like, oh, the Wi-Fi sucks, right? Which is, yeah, maybe that's true, maybe it's not true, right? But you need a little bit more information in a lot of cases to really define these issues. So it's important to do that, right? Because that's going to help you understand where to start looking. Especially on Wyebot, right? When you're looking at the data, there's different ways you can analyze it. For example, if you're looking for area problems, with a whole wireless coverage area, we recommend looking at that issue detail section because that's going to look at all the events in the environment. It'll bubble up anything that's of interest, and that may help you understand. Oh yeah, my AP changed its channel, or there was a microwave oven operating and it caused a bunch of interference. Stuff like that is important to see. But if it's a specific end user, right, we have a tool called device forensics where you can actually analyze individual Wi-Fi clients and see if their specific device is having maybe an authentication problem or something like that. So we'll run through that in a bit, but some more screenshots for you. So here's what issue detail kind of looks like on the historical graph. You can see, it's just a kind of list of quantity of issues. It's color coded based on severity. So we have, minor, major, critical. And you can click around this graph and actually see all those events when they happened and what they were. So I'll show you that in just a minute on the live demo. RF analytics is also really a, useful, right, and important place to look because a lot of Wi-Fi issues are related to airtime usage, right? The channel being too busy, too many transmissions, too much interference, all sorts of stuff, right? So we can, look at that, analyze it, again, with historical data is available here, as well as spectrum data. So if you have a source of interference like a microwave oven or a Bluetooth device or whatever it is, right, we can help you identify that with the RF analytics tool. So another very important place to be aware of and look on your dashboard. Let me just check the time here. Oh yeah, we're good. Yeah, and then issue detail. It does break it down by severity, right? So you can see the color code. Here we have a few major issues and a minor issue, and if there's a critical, it'd be red. That sort of thing. So you can know where to start, when you're breaking down these individual events and what to fix first, essentially. Now, device forensics, right? So when you're dealing with individual users, you can actually search for them on device forensics. You can search by MAC address or device host name. And when you search for them, you're going to find information about that device. Here we see just I think this is a Windows device, something like that. And we know information about their client Wi-Fi radio, how many spatial streams they have, which channel width they're going to support. And we're also going to give you information about issues they're having. So here's an example of a specific client issue, right? We're looking at a individual client here that had a high retry rate, which of course indicates this device was maybe having some issues with signal strength or interference that it's dealing with. And, when that happens, then you're going to see performance problems, right? So we're analyzing that on an individual user standpoint. So I'm going to come back to this slide in a minute. Let me actually switch over to our little demonstration dashboard here and talk about some of this stuff in more detail. Okay, so here I have a couple sensors. These are actually my home lab environment, but I have a whole bunch of stuff set up on these to, maybe give you folks some ideas as far as how you'd want to use your sensors. But we can see, right, at this screen, this is kind of the top level view. And this is what you see initially when you log in. And you can get an idea of how things are going, right? So I have a couple sensors. They are reporting quite a few issues, right? And you can sort by quantity of issues if you want. They're major. So the color on this little circle is going to indicate the severity of the issues. So we have major issues on both of these sensors. So we'll take a look at what those might be. And you also see this network test analytics, right? And I always recommend you look at this as well, because this will tell you, are a bunch of my tests failing, right? And maybe are they failing for a certain reason? Is my DHCP response time, DNS, radius, right? All this stuff is given to you on some nice, like I talked about, everybody likes pie charts, right? So you can see that and understand that pretty quickly. Now, you can click on this as well. And when you do that, you'll see there's more information at your fingertips. You can extend the time range that we're analyzing over. So you can go up to a full month in the past. You can look at each SSID that's being tested or the wired testing performance, and just look at that granular performance, on a per test basis, and the response time of the various services, right? So that's kind of the top level of your dashboard. Okay. Now, if I click on a sensor, let's look at this sensor B. This one happens to have more issues right now. So I'll click on that. And it takes us into this screen. Now, obviously, you can see this screen has a lot more to look at because we're now at the sensor point of view. The sensor's doing all these different tests. We'll talk about these in just a little bit. And then, of course, it's analyzing issues, seeing clients, all this good stuff. Now, I want to talk about some of these issues first. All right, because this is where I always recommend you just take a look, see if there's anything that's obvious in here that's potentially causing, performance problems for everybody on the Wi-Fi. So if I look at this, we can see there's a couple things. Classic one here, right? I'm running a whole bunch of SSIDs in my lab. You shouldn't do this in the real world, right? But I guess it's a good example to have, for demonstration here. General best practice with Wi-Fi is you just want to minimize the number of SSIDs as best as you can. Because every SSID you advertise has to send out management traffic to let people know that it's available. And that's with beacon frames, that's with probe request or probe responses, stuff like that. That really contributes to airtime congestion. So limiting that's important. And that's what our solution's explaining. Essentially, we recommend just a general guideline is limiting it to no more than 4 SSIDs per radio, right? Per access point. So we see I have 8, which is a lot, right? So that's a major issue, in fact, because of that quantity of SSIDs. What else we got going on? Legacy data rates. This is also very common. So if your APs are configured with default settings, or you maybe spin up a new SSID and you forgot to change this, it's probably supporting 802.11b, which is the first Wi-Fi standard that was really, popular on the market. So late 90s up to, early 2000s, Wi-Fi was using the B data rates, and B data rates are different than the other data rates because they're very, very slow. They have 1 megabit per second support, for example, which, as you can imagine, right, a 1 meg transmission takes a very long time, and it uses a lot of time on the channel, and you get higher channel utilization because of that. So again, major issue, in fact, because all your management traffic from your AP is sent at whatever the lowest data rate is, right? So this is a big thing to fix if you have this this flagged for you. So yeah, another example there. Now, there is historical data. So if I click on this blue button, you can see we can go back in time for 30 full days in the past. So if I just click on this, you'll see this loads here. And now we have a whole bunch of data we can click through. And the nice thing about this is, most Wi-Fi issues that you deal with are intermittent. If it's going to generate a ticket, it's because, you're in a boardroom and people are doing a Zoom meeting or something like that, and it just didn't go well, right? There was some problem with it, and if it was a Wi-Fi problem, you're not there live to capture it in most cases. So having a sensor there means you can go back in time. So let me just pick on a date. So here we look at, what is this? Tuesday, 11 a.m. Click on that point in time, and if you look at this down here at the bottom, we get all these issues that were detected at that moment. So if I go through my list of issues, I can see a few things that really jump out at me. Major issues with configuration are still there. Legacy data rates were still turned on. Channel widths are a problem, right? I mean, I shouldn't be using 80 megahertz, but I am. In an enterprise, definitely don't be using 80 megahertz. I mean, I'm in my home environment here where I can get away with it in some sense because I can use DFS channels. But if you're in a school or something like that, that's not a good idea. But also, I see here, right? Let's scroll down a little bit. Well, look at this. Radio changed its channel. Well, that is we consider this a minor issue because it happens in normal operation quite a lot. But if I'm a client and I'm connected to an AP and I'm doing a Zoom call and that AP changes its channel, well, there's going to be a few seconds there where that AP is not servicing Wi-Fi anymore, right? It has to disable and re-enable its adapter. And that takes some time. right? So if you see that happen, well, that actually may be the root cause of disconnections. Now, we also see evidence of interference here. So there was a microwave oven operating at this time. So any clients on the 2.4 band may have had to deal with this interference, which is actually coming from a built-in spectrum analyzer on these, said that kind of weird, spectrum analyzer on the sensor, right? What else? Disconnections. I mean, so there's a whole bunch of stuff, right? But the point is, if you don't know why something went wrong, right? Check here first, because it might just highlight for you exactly what the problem was. And, we give the advice to fix these things. So that way going forward, that problem hopefully doesn't reoccur, right? So that's the issue detail. And again, just wanted to jump out there, point that out to you. Now let me switch to another sensor just for the sake of variety. And we can also look at the client device forensics here. So every Wi-Fi or Wyebot sensor will detect the nearest Wi-Fi clients to it. So if you click on the Wi-Fi clients tile, you can see who that might be. If it loads today, there we go. My internet's a little bit slow. But we can see, I have a handful of devices that are connected to the Wi-Fi in the area. And I can pick on any of these specific devices and find out issues and events about them. So you can see there's magnifying glasses, right? So let me just pick on something. What do I want to look at today? Maybe my Chromecast, which I have in my TV in the living room here. So click on that magnifying glass, takes us to this screen. Now we're going to see some information about this device. So we do know the name of it. I named this device so I can recognize it. We know it's chipset vendor. It's a Google Wi-Fi card, which is kind of interesting, and it uses the AC standards. So not the newest of the new, but I mean sufficient enough for a set-top box type of device. Now the client status will show you which signal strength it's detected at, which channel, which AP it's on, which SSID. Obviously important to know. But I think the more interesting information is actually on this historical chart. Okay, because this gives you 30 days of data for a specific user. And we can see this device actually is, pretty often having some type of Wi-Fi issue. So if I click on these little points in this graph, you can see at the bottom what that problem might be. And here we're seeing that this device has some high retry rates, right? Well, there you go, right? That's a pretty classic example of, Wi-Fi performance problems. We measure that on a per client basis. And, the higher the retry rate, the more noticeable latency issues, slowdowns are going to have, especially if you're dealing with real-time stuff or live streaming video. It's a very latency sensitive process, as you can imagine. So when retries are going up, that means it takes longer to get transmissions to go through successfully. So we have visibility into that type of thing. Let's see what else we have. Client attempting to connect with the AP not responding to it. That's no good, right? I think my AP was acting a little strange at that time. Maybe it saw some type of radar event and then changed its channel. But yeah, so you can see this information on a per client basis. Now, this is also a searchable tool, right? So there's the search bar at the top. You can also just click on device forensic on the left-hand side and, just start typing a MAC address or a, device host name, and then analyze those individual users. And so when you're dealing with individual Wi-Fi clients, check there, right? Because that may just show you, oh yeah, there in fact was a retry problem, or, better yet, not better, but easier to explain, right? Maybe authentication. They just have the wrong password, or they have a bad certificate on their device, right? So that type of thing can be exposed to you very easily with device forensics. What else do we want to talk about here? RF analytics, definitely, right? So this is giving you stats on airtime utilization. And again, I always recommend you check here. And all this data, right, is historically available. So let me show you first what RF analytics is giving you. So this is airtime use, right? So I can see here my channel 11 is pretty highly used, right? 60% just about, which, being that I'm kind of in a sort of a townhouse situation, I have neighbors that I can hear their Wi-Fi and they're bleeding into my network. And if you're in a school that's near residential, you're going to see some of this as well, right? And that causes excessive airtime use in a lot of cases. 5 gig's pretty clean though, which is nice. Now, if you do expand that, you can see we actually break down the Wi-Fi traffic when it comes in, and we want to determine what type of traffic it is that's causing airtime usage. So in terms of the Wi-Fi standard, there's actually 3 defined frame types you're going to see. Those are management, control, and data frames. Now, Now, not everybody has to know like what's a management frame versus what's a control frame versus what's a data frame. Just generally, management frames are going to be things that deal with, advertising the access points, beacon frames, responding to clients when they, ask to connect, like, association responses, probe responses. So you're always going to see a lot of this, right? There's a lot of management frames. Now, when you have low data rates enabled, like 802.11b, your management frames are always set at your lowest data rate. So that's why we really recommend raising that up, at least to some extent, so you're not having an excessive amount of overhead due to the low speed of transmissions. Now, control and data frames, those are more associated with clients. So what I mean by that, data frames, obviously, maybe not obviously, right? But the thing with data frame is that's the actual frame that's going to have the ones and zeros that are transmitted that need to go to the switch and then to the internet or somewhere else on the network, right? And the control frames, for the most part, not all of them, but most of them are going to be responses to data frames or any other unicast transmission. So it's acknowledgements, basically. So Wi-Fi has an ACK system, kind of like TCP. If you're familiar with that, right? Where every frame that gets sent has to get an acknowledgement and response. And that's a lot of what control frames are. Now, there's also interference, which is going to be anything else, essentially. So when I say that, I mean microwave ovens, Bluetooth, cordless phones, Wi-Fi transmissions that are corrupted or on adjacent channels, right? That type of thing is going to cause interference. And we record how much of that's out there, and we can see here quite a lot. Now, we also do mention any individual client that's using a lot of the airtime. So this is a Wi-Fi device using about 3%. That's not a ton for one device to use. But, if you had a device, one example, maybe you have a bunch of Chromebooks, right? And they're doing a OS update, which may be multiple gigabytes of data, right? Well, while that's getting downloaded, they're going to access the channel very frequently, and they may start using a lot of the airtime, right? So we record those individual users so you can see that. Now, this is all nice, right? But historical data, I think, is much more important when you're analyzing this type of thing, because you can see the trends. And that's really the main, I think, value with this is if I look at this, one thing I would assess right now is that the 2.4 gigahertz band in this environment is, you're not going to have a great experience on it, right? Because you see the airtime use is frequently extremely high. I mean, it's getting above 75%. Sometimes it's up to almost 90%, right? And that means 90% of the time, but when I want to transmit, I can't, right? The channel's busy. So you get a lot of, degraded performance due to that. Now, 5 gig, this, depending on everybody's environment, it might be a little bit different. Here we can see my 5 gig has been historically pretty good, pretty clean. Now, there was a point in time, I thought this was interesting. What was I doing here? I think I was downloading some huge file, and one of my devices was doing that. And you see the airtime use spiked up extremely high for maybe an hour or so, and then it went back down, right? So you can see those trends, and it's really informative because, if you have one of those big slowdown events and you don't know why it happened, well, look at your airtime use, because it could have just been a device or two doing a huge download, could have been a big spike of interference, and we give you that data, which is important. Now, the graph type can be changed to non-Wi-Fi interference. Now, if I do that, you can see I basically had continuous interference here. But if I click through this, you can see what it might be. In this case, microwave oven was the source of interference for me. Sometimes you get some other type of stuff. Yeah, microwaves are pretty common. Possible interferers may happen if you have other sort of oddball things like, I don't know. It could be anything really. But if it causes interference, we tell you the channel it is, the start and end time of those events, and for the most part, we can pattern match if it's like microwaves or Bluetooth or cordless phones, wireless cameras. There's lots of stuff that we identify as well. All right, so that's the RF analytics. In a nutshell, and I think I'm going to go back to my slide deck and talk a little bit about the network testing. So we're going to zip back over here to the slides. There we are. All right, next slide. So classic question you may have is the problem you're seeing really a Wi-Fi problem, right? So what I mean by that is, almost every ticket you're going to get these days from an end user is going to say, oh, the Wi-Fi is not working, right? Now, is it always the Wi-Fi? Well, a lot of times it's not the Wi-Fi, actually. Wi-Fi is pretty resilient. It's a pretty robust technology, yeah, it's not always the fastest thing in the world, but it usually works, right? At the end of the day, you'll be able to get some transmission through. So what are the problems you might be seeing? Well, websites being down, as we all can agree, that's not a Wi-Fi problem, right? That's the problem with the web server somewhere else, not even your web server, right? That's out on the internet. And, so that's one, example there. Websites being slow response times to specific websites. Again, probably not necessarily Wi-Fi. It could be the, performance issues on their end, performance issues with the ISP. Individual user devices having problems like being full on storage, being out of RAM, having high CPU utilization, DNS, ISP, the classic, right? Layer 8 issues, user error, you're going to see those, I think, more frequently than anything else. Yeah, not Wi-Fi. So for problems like these and determining whether or not they are Wi-Fi issues, Wyebot has this ability to connect to the network and run tests. And that'll validate that things are working or not, right, as you expect. And there's also notifications built around this, so you can get alerting and make use of that. So just for an example of this, and we're going to get into more detail on this in just a second, but we have a screenshot here of an Office 365 test we were running on one of our test sensors here. And what you can see from the results of this, a couple things, right? Now, we see there's kind of a red dotted line here. That's because we're running a test against OneDrive and it's not responding, right? It's down, okay? So that's a website outage, not Wi-Fi there. Now, we also see Outlook had a high latency spike, right? We go back in time here, we see there was one that was almost 6 seconds in response time. So you get nice data, response time as well as availability with some of these testing. And so I'm going to zip back over. Yeah, so I'm going to go back over to my demo and show you some actual tests live and maybe give you some ideas to how you can use those. All right, so here we are back on the dashboard. So you see if I scroll down, I have all these different charts. These are for the different tests that I have configured to run on this sensor. And that's the main thing, right, is these are completely customizable. Yes, you can set up a default set of tests, which includes some basic things and some kind of well-rounded functionality. But, I really encourage you to set up custom tests that are specific to your needs. So that way the data Wyebot's giving you is, as useful as possible, right? So why don't we just look at a couple of these, maybe give you some ideas, right? So we have one thing that we do, it's called application testing. So let's click on this, this test here. So I like this because it's got some good data in it for this demonstration. I'm running a test on one of my Wi-Fi SSIDs. Now we do support enterprise authentication, which is kind of cool. So we're actually authenticating here as a Radius user. We also get an IP address. Every time we run a test, we're doing the full connection. So we're connecting to the AP, getting an IP, measuring response time along the way. Now, this is all custom here, what I've done, right? And you could easily set up a similar type of test for your environment. I have some home lab equipment that's running some web-based things, web servers. I have, DNS servers. I have, Grafana kind of web interface, all sorts of stuff, right? And so I have a test that's going to each of these different web servers and measuring response time and availability. Now, I also record DNS time with this, so you can see if it's a host name, we have to resolve it and see how long that takes. But I wanted to show you some of the data here and maybe how we can understand a problem. All right, let's look at the other one because this one has a gap, which isn't ideal. But let's look at this graph here. Here we go. All right, so we can see there's several different hosts here. Now, I can uncheck any of these little circles to hide the data I don't care about at the time. But one thing I wanted to show you is there's this kind of a, what do you call this, teal, this color for this 10.0.10.64/admin web server. And if you look at this, you see the response time has been trending upwards. It's been going up and up and up and up. And this is a week of data. Let's go back in time even further. I can do a month. And you can see it's even more dramatic when I go this view. So it's been pretty stable for a while, then started to trend up, then went back down, and then it got pretty high. It's trending up higher and higher and higher. And eventually I got to, what's this highest result? Click and drag, zoom in, almost 7 seconds, which is pretty wild for a locally hosted, web server. Now this is a Raspberry Pi. actually. That's running it's called a Pi-hole DNS. So if you're familiar with that home lab type of stuff, that's a pretty cool DNS thing that blocks ads for you if you don't like advertisements. I suggest you look into that for your home network. But anyway, you see here, it's that response time got very high. And then what happened? Well, let's zoom in a little bit even more. And let me hide some of these other items so we can make this more clear. If you look at this, there is a failure, a stretch of failures from 1:20 a.m. to 3:20 a.m., 2 hours. Now, if I click on these failures, we scroll down. If you look at this, both of my web servers hosted on this Raspberry Pi were unreachable, right? And then it came back. And if you look at the response time, it's much lower now. So what's up with this, right? Well, what happened is I had a memory leak on this device, and the some software running was basically, not cleaning itself up properly, and the RAM utilization got out of hand, started to trend up. And then I found that was just causing tons of issues. So I went and actually, it went down, stopped working, and then eventually I had to go and reboot it. And now it's back and it's better, right? But we can use this to identify these types of trends. Of course, this is just a custom test, one example. Now, you can also set up notifications. So if I set up alerts on this, I could get an email notification if this failed a few times in a row. And then I know, oh, geez, my DNS server here is down. I need to go fix it, right? So that's one example of a custom test. Now, I could change this graph type, by the way. So if I go to here, I can go to like radius response time and see if that's been stable, which fortunately for me, it has, right? So I can see the response time for my radius server has been very good. My DHCP, we can look at this as well. This one's been pretty stable, surprisingly. There was like one time where I saw maybe a third of a second, but usually it's just a couple milliseconds, which is pretty nice, right? So anyway, one example, right? You see there's lots of data you can get out of that. Now just to show you real quick how to set up custom tests. You click on the network test tab on the left-hand side, okay? And this is where you're going to be able to administrate your tests. Now, I should say there is one prerequisite for running network tests, and that's to have your SSIDs set up on the My SSIDs page. So if you click on this, you'll see you can add credentials for any of your networks, as many networks as you want. I have a whole bunch going on here, right? So we have password protected networks, radius protected networks. We support, the PEEP type where you have username credentials. You can do ETLS, which is certificates. What else have I got going on here? Open enhanced, captive portal stuff. So anyway, but you want to set this stuff up first, because if we have the credentials, then we can connect to these SSIDs to run tests. Now we can also run tests on the Ethernet. In that case, you don't need to enter any credentials. We'll just use whatever VLAN that we're plugged into for that. But with the network tests, you can add individual test profiles. So I click on this button here. So I want to talk about a couple of these options you have. Now the application test is the one we just went over on that graph. So you can add URLs, right? Now this is really important for things like, we're talking schools, student information systems, statewide testing, productivity suites as well, like Office 365, Microsoft Teams, all this stuff, right? It's web-based. There's web servers on the back end. So you want to add those URLs for these things so the Wyebot sensor can connect to them and measure response time. And then if it goes down, trigger notifications, right? We also have, video and voice simulations. So we can actually do a simulated video call, a simulated voice call. So if you're having issues with latency or jitter on your network and you want to see if that's going to degrade real-time communication for things like voice and video, we actually simulate that traffic and find out metrics for you. And you can pick different vendors like Google Meet, WebEx, Teams, Zoom, custom. If you want to mess around with your own bandwidth and packet size values, you can certainly do that. But yeah, this is a nice place to mess around as well. Last thing here to mention, Link Doctor. So Link Doctor, real quick, I'm going to go back to our graphs and explain this. So let's pick on one of my Link Doctor tests. Here we go. So Link Doctor, what it's doing is basic diagnostics of your network connection, but it shows you if there's a problem, where that problem happens. So we see all these steps, right? Wireless connection, DHCP, make sure the gateway, DNS server are reachable, public IP is reachable so we can get up to the internet, resolve a host name. So make sure DNS is actually working, right? And giving you a valid, IP address. And finally, pinging that host name. So hopefully it can all successfully come together. So just looking at this, there's one result here I thought was interesting. So let's click on that point in time. What happened? Well, wireless connection failed. Why did it fail? It says right here, my radius server was down, right? So that's obviously not good. It seemed to have resolved itself, right? But with the link doctor test, it gives you a graph so you can see very quickly, where it's failing, right? It could just be an internet connection not working. It could be your DNS server's down, in this case, radius, right? And that's going to make sure everything else doesn't work, because if you can't get connected to the network, you can't do anything else after that point. So anyway, so that's the link doctor graph. Now, with the link doctor test, okay, there are some cool options with it. So when you set up a test, you pick the interface. You can do Ethernet, Wi-Fi, or actually both wired and Wi-Fi. Select your SSID. And this is where it's important to have already set up your SSIDs with credentials. So we see all these different options here. And I'll just pick one of my radius networks. Now, the AP selection, you can leave this on auto. And in fact, you may want to, just because you generally want sensor to connect to APs like clients do by picking the available closest one. It's easier to set it up when you have multiple sensors like that. However, you may want to pick specific APs, because there can be a circumstance where you have an AP that maybe isn't working right, and you want to make sure your sensor is actually connecting to that AP that you specify. So you see here, I have 2 APs nearby in my home lab, and I can connect to either one of these, right? I can force the sensor to connect to that AP for the test. So that's handy, especially for ad hoc troubleshooting and getting some analytics on specific radios. Now, there's a multiple AP test as well. Now, this is exclusive to the link doctor test, but this allows you to test up to 6 APs. So let's just say you have a sensor, you stick it in a dense environment like a cafeteria, auditorium, something like that, where you have multiple APs that cover the same general area. You can use this link doctor multiple AP function to actually round robin between those access points. So over time, you may find out that you have an AP that's not working, right? Which happens. You have bad cables, you have VLAN mismatch, things like that. And you may not be aware of it, because most end user client devices are pretty good these days. If they find an AP and they can't get out to the internet for some reason, they may just try to associate to a different AP, right? But this test will actually make sure that those APs in the area are functioning, hopefully the way that you want them to. All right. Down here, you can see the scheduling options. So all these tests can be run on a schedule, and you can set that to be more or less often, depending on your needs. So we could see, once every 10 minutes is our most frequent option, or as infrequent as once a day. There's also a smart scheduling. Just to really quickly explain what that means. If you have multiple sensors in a location, so let's just say you're a school building with 20 sensors deployed, right? You may not want all of your sensors to run a given test simultaneously. That's especially important for things like speed tests, right? If you run a speed test with 20 sensors at the same time, well, you're not really going to get useful results out of that, because they're all trying to hit the circuit at the same time, right? So they're not going to be able to max out the throughput the way you expect, and also it's not really great for your network to do that, right? So smart scheduling allows the sensors to synchronize themselves or orchestrate themselves so they don't simultaneously run a test. That's what that's for, okay? But if you actually want the test to run simultaneously, you can uncheck this. And now you can actually manually pick the start hour and minute when that test will start to run. So you have another option there as well. It's up to you, right, how you want to do that. But there's options there. I encourage you to use smart scheduling unless you have a reason not to. It's nice just to have your sensors sort of load balance a little bit and get more kind of spread out data. It's better for your network as well, usually. Now, notification profiles. I'll explain this, right? So this is where you get those email alerts that are important for your proactive aspect of the solution. So we see here, I don't have one turned on for this particular test. I have a few different options though, like one that's just a placeholder, which I probably should name something a little more useful, but I also have like 2 consecutive failures, right? So maybe I want to get alerted if this fails twice in a row. Now, these are all set up actually in a different place on your dashboard. You're going to want to go to Management and Notification Profiles, and then you'll be able to create alerting rules. So you click on Notification Profile here, and the interface is pretty straightforward with this. What you're going to want to do is name it something that makes sense. Normally I'd recommend just name it what the profile is going to do, like trigger if it fails 6 times in 24 hours, right? Just because that's easy to understand. Now you also are going to want to assign users. So these are the targets that are going to receive email alerts when that profile is triggered. Okay. So you're actually able to set up multiple profiles that go to different users. So not every user needs to get alerted with every test, right? So that's why we let you do it like this. And you see the trigger criteria. So we have a few options. They're mostly pretty self-explanatory. The one that I want to explain, though, is this notifying every transition. What this means is if I have a test that was passing, all right, and then that test started to fail, you would get an alert that first time it failed. Okay. Now, if the test continued to fail, you wouldn't get another alert, right? Because it's not really had a state change yet. But once it starts to pass again, you'll get another email. So that's kind of it's a nice way to do it if you wanted to just know like when things go down and when they come back up, because that may happen if you have like an intermittent ISP outage, right? You can also get notified every time a test fails. Of course, we know what that means, right? You get a lot of alerts, which is useful if you have like a test going to like your core switch or something really critical. You want to make sure that that's always available, right? That's a good use case for that alerting system, I suppose. Now, there's also consecutive failures or density of failures, so number of failures within a time range. Yeah, especially for things like, if you're going to test like a website on the internet and that just goes down or doesn't respond one time, may not warrant an email notification, right? So you can kind of specify that a little bit and have your alerts apply in a way that makes sense. Last thing to real quick explain here with these alerts. So under users here, you of course can administrate your users for your Wyebot dashboard. We do support single sign-on as well. But you can also add what we call a notification user type. Now, what this does is, or the reason we have this, right? If you have an email group that receives alerts, and that's how you prefer to use this, like maybe a knock email group, something like that, you can add that as a user to your dashboard. So if I go in here, type in like, pretend we have or maybe support at wyebot.com, right? That's our support inbox, and maybe that's where we want our email alerts to go. We can add that as a notification user. Now, why would you do that? Well, with notification users, they don't actually have to set a password because this user account can't actually log into your dashboard. All it is just a placeholder thing here so you can target that for email alerts, right? So that's what notification users are for. Just letting you know that's there. We also recently added do not disturb options. So every single user can set times that they're not wanting to get alerts, and these will be mute. The alerts will be muted during those times. So I could click on Monday and say, I don't want to get alerts from 6 p.m. up until 8 a.m. Right? So if you do the start time is kind of a later time than the end time, it's going to traverse the overnight boundary. So you can do overnight mutes with that. So yeah, every user can set these. You can set your time zone as well to make sure this is relevant to you. But yeah, so that's just letting you know that's their pretty new addition to our technology. So I always like to highlight that stuff. All right, last thing with notifications to explain. So once you have those profiles set up, you apply them to each test that warrants a notification. So if I click on one of these, like this DNS test here, I can set my profile to whatever I want, right? And once you have that done, now you're going to get alerts, when those criteria are met to trigger said alert. Okay. So yeah, I know we just got a few minutes left, and that's kind of what I wanted to run through as far as the live demo. So now I think I'd like to turn it over to Adam and do a little bit of Q&A time.